Hi, and welcome to this clip having a look at how we can recognize singly occupied orbitals in A-level questions. It usually turns up in multiple choice questions, so I found one that we can have a look at. Example. So you can see the term there, which element has the atoms with the greatest number of singly occupied orbitals. So to go about this, we firstly write out the orbital configuration for each of our choices. So taking the periodic table and going to the actual cell that you find the atom in, you'll remember from GCSE that the number of protons equals the number of electrons. So therefore carbon has 6 electrons. So what we do is we apply the normal orbital filling rules, filling energy level 1 first, so 1s2, and then energy level 2, 2s2 and 2p2. All the numbers in pink, remember, have to add up to 6 because the number of protons and electrons are equal, like we just said. So doing the same for chlorine, we get this. And for calcium, there are 20 electrons, so calcium will look like that. And for gallium, there's 31 electrons, so gallium will look like this at the bottom. So we need to think about what a singly occupied orbital might now mean. So if we turn to the box notation, we can see quite easily what a singly occupied orbital is. So the ones that are highlighted are singly occupied. So what we need to do is apply this idea to the elements in our question. So if we take carbon first of all, you can see it's got 1s2, 2s2, 2p2. So if I get my laser pointer, these two are both singly unoccupied. Now remember, we're looking for the greatest number of singly unoccupied orbitals. So let's see what happens when we do the same for the others. So for chlorine, you can see here there's only one singly occupied orbital. So straight away, chlorine is not one of the answers that we want to consider. Now, this technique, although it introduces how to think through it, I'm going to show you a way of doing it a bit quicker. So when you come time to do one of your own, you can use this quicker technique. So if you look at calcium, all the S's are full because they have 2 in them. All the P's are full because they have 6 in them. So therefore, there are no singly occupied orbitals. So you don't even have to bother doing the box notation. You can kind of shortcut it. If we go to the next one, you can see that there's only one singly occupied orbital, and that's going to be 4p1. So that's going to be p subshell, like this one. This is a 3p subshell. A 4p subshell will look the same, but it will just have one electron. So that only has one singly occupied orbital. So remember what the thing we're looking for is the greatest number. So now we can start to come back to our carbon and our chlorine. We have 2 singly occupied orbitals in the carbon atom. So if we remember, those are our 2 singly occupied orbitals. So that must mean our answer is A. Okay, thanks for listening. Until next time, see you soon.